Welcome students. Today we will discuss about nested grid search method. This technique is in continuation of our previous video, that is a standard grid search technique. So in standard grid search technique, we have discretized the search space. Say for example, if this is x1, x2, instead of evaluating the objective function at all spaces, we will quantize or we will perform or apply the objective function at discrete spaces. So say for example, so instead of applying all these points, I will evaluate the objective function only at discrete places like this. So by evaluating the objective function, we found out the optimum solution, optimum x, or you can say as a optimum x star, whatever it is. So it can be either this one, any point, it can be either this point or any point, any of the 9 points. In nested grid search algorithm, we want to improvise the algorithm by refining the search space. Say for example, you can see this algorithm in the initial wise, this is the lower range, this is the upper range. Let us suppose for x1, similarly for x2, this is the higher range, this is the lower range. So here in nested grid search algorithm, we will run the grid search algorithm at multiple levels with different values of lower range and upper range and step size. That is the difference. So I will write clearly. So in grid search algorithm, we run the grid search same standard grid search technique method with different step sizes, with different lower range and upper range, lower range and higher range, values for each level. So this is what is happening in the nested grid. In nested grid algorithm, we will run the same standard grid search method, but with different step sizes and different lower and higher ranges for each level until we get optimum solution. And this nested grid search technique we will perform around the optimum point. We will perform the searching around the optimum solution only. Okay. Say for example, in our first level, if I found out this is the optimum solution, that is the middle point, this is the optimum solution. During the second level, what I will do means, I will decrease the range. So around this optimum point, so corresponding to this optimum point, I will modify the lower range for x1, that means I will change this lower to L1. Similarly, I will decrease the higher range to this one. This increment of lower range and decrement of higher range, it has to be done with respect to this optimum solution only, with respect to this optimum solution found in level 1. Similarly, for this level 1, you decrease the higher range and lower range for x2 also, another variable also. So correspondingly you will decrease to H2 and you will increase to L1. So previously we have searched over the entire space and we found out this is the optimum solution, which we call as x1 star. Now we decrease the lower range and upper range around this point for all the dimension, and now what we will do means we will search around the new regions. So corresponding to L1, you can see this is the new region. You can see this. This is the new region specified by the new lower range and upper range for the variables. Now with respect to this region, you will try to find the optimum solution x2 star dash. That means at level 1 you will find x1 star dash with new values of lower range and upper range. That means in the second level you will find x2 star dash. So if you specify n levels, you will get nth solution. So this final solution is what we call as a optimum solution. Okay. So at each level the search region will be decreased or synced so that we get more accurate optimum solution. The main reason for going this type of nested level is you will get more accurate solution. So that is the logic behind this nested grid search algorithm. Okay. So correspondingly we have to revise or improvise the previous algorithm by modifying the lower and upper ranges and step sizes with each level. So this is mainly introduced to get more accurate optimum solution by decreasing the lower range and upper range for all the values. So let us see what is the algorithm, how we will achieve that. Let us write the algorithm. Nested grid search algorithm. So first we will write the input to this algorithm. The only extra argument that we will give to the standard input is the number of levels. So we have to specify the number of levels. Apart from that, everything is same, number of levels. So you have to define the step size. It is also a vector of step size for all the variables, or you can see for each dimension, and the upper vector, it is a vector consisting of higher range for each variable or dimension, both are same, and lower we have to define this variable. It is also a vector type consisting of lower range values for each dimension, and finally you have to give the another input argument, the objective function. This is your objective function, and finally you have to specify that type, whether it is min or max. So for this algorithm, the output is a list. Output is a list break. The output consists of a list object with different elements S dollar, the optimum solution, comma, and its evaluated value. So now we will see what are the steps involved in this. What are the steps involved in this? Step 1, we have to define the function, define the name of the function. Here we are doing a nested grid search. So here the input arguments is same as standard grid search, except here we are having the number of levels. So this is first argument, and the second argument is step size. In fact, step size is variable throughout each level, so we will see that. And then the lower vector, upper vector, and then the objective function and its type, whether it is min or max. So next step is step 2. Let us see what are the steps involved in this. So let us define a while loop. So we want to run a loop of statements which consists of performing the grid search repeatedly for n number of levels with a different step size. Let us see how it is achievable. So step 3, and then we will call the standard grid search technique with step size and the lower vector, upper vector, and then your objective function and type. After calling this, you will get one optimized solution, but it will be the first step. So now we have to check whether it is a first level or not. So let us define a variable I is equal to 1, I less than level. So for each level you have to run the grid search algorithm. So you can define a variable something like here I is equal to 1, you better initialize it. This is for loop purpose only. And step 5, if I is less than level, then you have to modify the step size, because in the next iteration you have to accurately find the optimum solution. For that reason we are decreasing the step level. Coming to step 6, you have to change the upper range of values and lower range of values. So for that we are defining one parameter called as interval, which is defined as upper minus lower vector by 4. Okay, I will tell what is this. So by using this interval we can change the lower vector. Here in the previous slide I already told you, you can see this. Here you can see this is the for x1 this is the initial lower range and this is the initial upper range. In the next level this lower range gets changed to L1 and this H is decreased to H1. So by how much means by using this formula. So you can see this, we are using a formula based on the interval size. So lower range is changed with the help of this formula. This is based on the max of the lower vector, that means whichever is maximum, and your solution S dollar solution minus interval. So whichever is maximum, you will assign that as a lower one. So obviously you can see in my previous slide, you can see the low range, it gets incremented to L1. So there initially you can see this is the big range of search space. So during the second level, what we are doing is we are changing it to L1 around the solution vector, okay, around the solution vector, and H is decreased. So initially you are having all this big range of solution space. Now we are decreasing the search range with the help of this vector, okay, this formula. So similarly, in step 8, we have to modify the upper vector as the min of upper range, because we have to decrease the upper range. So we have to use the minimum function, and S dollar of solution plus interval. So this is the formula we are using. Whichever is minimum, we are going to assign it to the as upper range, okay. So this is a step 8, and finally once it is over, you can close the if loop. End if loop, and in step 10 you have to check whether we reached the number of levels or not. If I greater than or equal to levels, or if the difference between upper range minus lower range is less than or equal to step size, then we have to break the while loop. Step 11 is we have to break the while loop. So we will add the statement here. And finally, in step 12, you can close end if statement. In step 13, you can close the end while. I think end while is here. End while. Okay, that means you are running the loop continuously for different levels with different step size and lower range, upper range respectively. In step 14, you will close the end function, okay. In this way, you can perform the nested grid search algorithm, okay. So for better understanding, you can draw this also. This statements belongs to if loop, and this statement is belonging to this if statement, and whereas the whole statements from the whole if statement, they are all present in while loop, okay. So that is about nested grid search algorithm. I will, so you can read it once again. So the logic is simple thing. You have to give the arguments, one of the argument as a level, and while you have to run the grid search algorithm up to n number of levels. At each level, you have to decrease the step size, you have to increase the lower value, and you have to decrease the upper range, okay. So that is what is happening here. So in fact, by doing this, we can get more accurate optimum solution. So initially, say for example, if the search space is something like this, if you are searching this is the whole search space. In the first level, you will perform the searching over this entire area. This is a L1 and this is upper value H1. Similarly, this is a H1, this is a L1. So for differentiation, this is X1 parameter and this is a X2 parameter. I will differentiate with the help of dash. Okay, L1 dash, this is L1. So during this is at first level. Okay, this is first level. You can write as a first level. So during second level, what we will do is we will decrease the size. So say for example, if you found the optimum value at first level as in this location, what you do is with respect to this position, you construct a new search area. How you can do this is by increasing the L1 size. So by using this formula, you can see this. So new L1 and similarly H1 is also decreased. H1. So here also L1 is increased to L1 dash. So for differentiation, I will put L2 H2. Here also for differentiation during the second level, L2 dash H2 dash. So by doing this, what we will do is we will construct a new search area. Okay, this is the new solution space. So for this solution space, which is constructed at as per this new old optimization, we will find out new optimum solution. Okay. With respect to this, again you modify the search area and again you will apply the grid search algorithm. Likewise, you have to repeatedly apply the grid search algorithm up to n number of levels. So you have to apply the grid search technique up to n number of levels. At each level, the step size is different. Okay. So by doing this, you can find more accurate or reasonable optimum solution. Okay. Thank you, students.